Hey everyone, so please have out your notebook and your pencil for notes. Chapter 6.2, linear equations in one variable and proportions. And over here on the left-hand side, as always, you can see in your book or this PDF or in your rental book, which if you don't have yet, we will be getting you this week. The 4 objectives are solving linear equations, which will be good review, solving linear equations containing fractions, even better review, solving proportions, solving problems using proportions, and identifying equations with no solution or infinite number of solutions. So it looks like a good review of Algebra 1 here. And I don't know if you guys had Algebra 1, if you had already started the integrated math, but we'll go on through. So this first part, it just gives you an example of a linear relationship here. And it looks like it's the relationship between a group's average level of depression in response to negative life events and the intensity of negative life events. And it looks like the higher the intensity of the negative life event, the greater the level of depression. Well, that makes sense, right? And then the equations that make up those lines, those linear relationships, are right here. And then it goes through, oh, sorry, you guys, early in the morning for me. It wants you to recognize why being able to look at an equation, you can recognize that it's a linear relationship, and it is right here. The highest exponent on the variable is 1. So the variable in this case is x, and it is not x squared, that would be a quadratic. It is not x cubed, that would be a cubic. It is not 5 to the power of x, that would be exponential. It is just x, and when it doesn't have an exponent, you know that it's just 1, right? And that's how we know by looking at an equation, but it's a linear relationship. Okay, now going on to solve. Okay, and that's kind of here, going on to solve a linear relationship. Okay. All right, and this is going down, and it's probably telling you right here, solving an equation is you need to make it balance. What you do to one side, you do to the other. When you are trying to isolate the variable, we are going to be doing PEMDAS, except backwards. So I think we did PEMDAS last chapter. Okay. The addition and multiplication properties, we don't really need to get into that right now. But all it's saying is if A and B are the same and you multiply them by a different number or add them to the same number, you're going to get the same answer. Okay, so if A is 5 and B is also 5, then A plus 6 is equal to B plus 6, right? Because both of those answers would give you 11, and you have a balanced equation. All right, and then it's the same for multiplication. You could just change this plus sign to a multiplication sign, and the answer instead of 11 would be 30, but you would still have a balanced equation. Okay, so in order to solve linear equations, there were 2 things that I just mentioned, and that was isolating the variable and balancing the equation. All right, so here it's just going through and giving you some examples of how you would solve these equations, right? X minus 3 equals 8. If you just add 3 to both sides, you have isolated the variable. X is equal to 11. You're using the inverse operation to cancel that variable out on, or to cancel that number out on the one side. And here, x plus 7 equals negative 15. Since we're adding 7, the inverse would be subtracting 7 from both sides. Okay, and you get x is equal to negative 22. 6 times x equals 30. We're going to use the inverse operation to isolate the variable. So we're going to divide both sides by 6. And it says dividing is actually the same as multiplying by 1/6. That's true. That'll come in handy when we are dealing with variables. And when they do that, they get x is equal to 5. And here we have x divided by 5 is equal to 9. So we want to multiply. The inverse operation this time is multiply both sides by 5. And your answer will be 45. Okay. All right, some examples. Using properties of equality to solve an equation. So the equation here is 2x plus 3. So if we take some number, multiply it by 2, and add 3, we get 17. We're going to use inverse operations, and it's going to look like the opposite of your order of operations. So the one that's being added instead of multiplied is the first one. We are going to move to the other side. Okay. So what I love about this book is that it really tells you what it's doing. The first step is to subtract 3 from both sides, right? And when you do that, you get 2x, because what happens here is these 3's cancel out. So you just have 2 x's on the left-hand side, is equal to 17 minus 3 is 14. And then look, and it tells you, this is so cool. So you can either always listen to me, or you can just take your notes out of the book. It's up to you. 2x divided by 2, because since it's multiplication, the inverse is divide. We're going to divide both sides by 2. And we have isolated the variable. X is equal to 7. And then what I love here is that they put it back into the equation. So they substitute in where the x was. They put a 7. So instead of 2 times x, we have 2 times 7. Then we add 3. So we get 2 times 7 is 14, plus 3, 17 is 17. Okay, so it is balanced. What I would love for you to do is, in your notes for sure, try this checkpoint. Okay, 4 times some number plus 5 is 29. The first thing you're going to do, it looks like, is subtract 5 from both sides, and then divide both sides by 4. So take a moment, pause this video, and try that. All right, and then down here, it just gives some more steps for solving a linear equation. Oh, these are this is when we're solving a linear equation with variables on both sides. So we have to first get all the variables on the same side. So here, the first thing they're going to do, we have an x on the left-hand side. X is on the left-hand side. Oh, it's not on both sides this time. Sorry, you guys, it's separated out. So the first thing they're going to do is distribute this 2. So 2 times x is 2x. 2 times negative 4 is negative 8. Then we're still subtracting 5x. It's still equal to negative 5. That hasn't changed. And here is what they're doing that they were just talking about, is combining. So we have 2 x's, and then we take away 5 x's, and that leaves us with negative 3 x's. Minus 8 equals negative 5. And then we're going to add 8 to both sides. Then you have negative 3 equals 3. It just wants us to, oh, that simplify was for the other thing. Then we're going to have to divide both sides by negative 3. Okay, so we have negative 3x divided by negative 3, and we also have 3 divided by negative 3. We have now successfully isolated our variable. We just have x is equal to negative 1. Step 4, check the proposed solution. I love how it makes us check this. So we're just going to substitute in everywhere we had that x, a negative 1. So see how this works really well with what we were just trying to do in our last chapter, which was simplify expressions. Okay, so inside the parentheses first, negative 1 minus 4 gives us negative 5. And then 2 times negative 5 is negative 10. and minus a negative 5. 10 minus a negative 5, this is tricky right here, you guys, is the same as negative 10 plus 5, which gives you negative 5 is equal to negative 5. Boom, goes the dynamite. We got that one completed. All right, please try this checkpoint. I believe this is a 6 times x minus 3 minus 10x equals negative 10. So it's the same steps. I would do distributive property first, then combine your variables, then solve just like the first time. All right. While you are trying that, since I don't know how to pause this, I'm going to be quiet for just a moment and somebody's asking me a question. Oh, let's see what the book wants us to read about here. What's the great question? What are the differences I'm supposed to do with algebraic expressions and algebraic equations? Oh, we talked about this before. An expression does not have an equal sign. An equation does have an equal sign, okay? So here at the end, we can't balance this because there's nothing on the other side, okay? You can just simplify those expressions if you don't have your x already. All right, next question, solve and check. This is what I was talking about, you guys. When we have a variable on both sides, you're gonna need to get those on the same side in order to isolate your variable. So read through this on your own. I'll just tell you what is happening. Like I said, you can either read the book and take notes on your own, or you can listen to the videos. So here, the first thing that we are doing, it is subtracting. So we have 5 x's on the left-hand side, we have 8 x's on the right-hand side, and we need to put those x's on the same side. You can't solve or isolate a variable if they're on different sides of the equation. So the first thing it did, and you could do this either way, I actually would have subtracted 5 x's from both sides to get a positive x value, but what they did was subtract 8 x's from both sides. So what that means is that on the right-hand side, those x's cancel out now. And on the left-hand side, we have 5x minus 8x, which gives us negative 3x. Minus 12 stays the same, and now we just have 24 left over on the right-hand side. So next, it's going to add 12 to both sides, so it cancels out on the left-hand side, and then we need to simplify 24 plus 12, which is equal to 36. And we have negative 3x on the left-hand side. Then we divide negative 3x times x equals 36. So we need to divide both sides by negative 3. So negative 3x divided by negative 3, also 36. Divided by negative 3, we get x is equal to negative 12, because we have a positive being divided by a negative. And then it checks by substituting negative 12 back into the equation on both sides where the x was. And we get a true statement that negative 72 is equal to negative 72. So we know our answer is correct. And I say this all of the time to math students taking a test. There is no reason to not know if you got a question correct or not. You may not always get to the correct question on a test, but you should always know if you have gotten it, because you can always check math. That's what's so great about it. All right, now your turn. Solve and check. 2x plus 9 equals 8x minus 3. First step, you need to get the x's on the same side of the equation. What I would do is subtract 2 x's from both sides first, and then you won't have to deal with negative numbers, but it's up to you. Pause here, do checkpoint 3. Example 4, solving a linear equation. What's different about this one? Oh, now we have to distribute, and we have variables on both sides. So the first thing this equation is going to do is distribute the 2 here, and also at the same time on the other side distribute this negative 3. I will say right here, this is where I see the most mistakes made by people all the way up through upper level maths, is distributing and forgetting the negative, okay? Leaving off the negative when you're distributing. So here we have 2 times x is 2x, 2 times -3 is -6x, minus 17 just stays the same, 13 stays the same, and then -3 times x is -3x, and -3 times +2 is -6. And this is where I see, and actually a lot of times the first negative shows up and then students forget that second negative. So they would have just put +6, but right here we have -6. All right, then what do we have? We add the -6 and the -17 and we get -23. And we add 13 and -6 and we get +7. Okay. Next, I bet they put the variables on the same side, adding 3 x's to both sides. Yep. So we have -3x, we add 3x, that leaves us with just 7, so those 3 x's, those -3 x's canceled out. When I add 3 x's to the other side, I have to combine it with these 2 x's, and that gives me, when I simplify, 5 x's. The -23 stays. Next, we add 23 to both sides. So now on the left-hand side, we have 30. On the right-hand side, we have 30. On the left-hand side, we have 5x. Now divide both sides by 5. 5x divided by 5, 30 divided by 5, and x is equal to 6. I'm not going to go back and check, but you can see what they did. Pause now and please try checkpoint 4. Distribute first, simplify, then get your variables on the same side. Linear equations with fractions. Fractions are fun. That's what the F stands for in fractions. It does not stand for whatever you're thinking in your head right now. All right, so let's see. This is exactly what I would have done here. In order to, because we have a denominator on the left-hand side of 2, and we have a denominator on the right-hand side of 5, if we find the least common multiple, the biggest number that those two numbers can both go into, and we multiply it, okay, we multiply both sides by that number, so we're not changing anything on your equation, okay, you can cancel out the denominators. And actually, the way I usually show it, if we have, let's say, 3x over 2 is equal to 8x over 5 minus 4, I usually just put the entire equation in parentheses, and I would put the 10 on the outside of the parentheses, because you have to multiply every term in that equation by the same number in order to make it work, okay? So now we're gonna distribute that 10 throughout the entire equation, okay? So, but here's the coolest thing, and we did this on purpose, if the denominator can go into the number that you're multiplying, okay, that cancels the denominator out. So 2 can go into 10 5 times, so what we end up with is 5 times 3x, okay, is equal to, and here 5 can go into 10 twice, so what we end up with is 2 times 8x, and then -4 times 10 is -40. So on the left-hand side, we actually have 5 times 3x, we actually have 15x equals 16x minus 4. And then I am going to, I guess, subtract 16x from both sides. I was going to do it the other way to get positive numbers, but I think that that would confuse you to have 0 on one side. So I'm going to subtract 16x's from both sides. So I get -1x is equal to -4. Then we need to divide both sides by -1. And x, and that's the other thing to remember when solving. When solving, you always need your variable to be positive. X is equal to positive 4. Negative 4 divided by negative 1 is positive 4. Let's make sure we got the same thing that they got. Oh no, what did I do, you guys? Look, I made a mistake and I don't want to start over. So let's just go back and fix it. I wrote negative 40 here, and then I wrote negative 4 here because my 0 got lost in the red. So everywhere I had negative 4, that was actually negative 40. Good job. If you caught that before I did, good job, good job. Okay. And that is why we check our work. All right, checkpoint 5, solve and check. Okay. The least common multiple here, the first thing to multiply the whole thing by the least, God, you guys, it's hard for me to talk and write at the same time. The LCM, so if we have I'll get you started. If we have a denominator of 3 and a denominator of 2, I would multiply that entire equation by anyone? 6. Okay, and it doesn't have to be the least common multiple. It could actually be any common multiple, but the least common multiple will give you the smallest numbers. Oh, there's a lot of examples in this, in these notes. Oh, look, it looks like we are moving into some real world problems. In the section opener, we introduce line graphs indicating a person with low sense, blah, blah, blah. These graphs can be modeled. So, okay, so going back to the original kind of part that it was talking about, those graphs. So we have our 2, this one corresponds to this. And what I was looking at is that my slope, since it's a steeper line, and I know this line, my slope is a lot bigger, so I know that had to match up. And also it tells you. Actually, let's do different colors for the different lines. Okay, and then high humor group. So this is interesting. It looks like high humor group. How would you describe somebody who has high humor versus low humor? I don't know. I feel like I have pretty low humor, so I'm not sure I'm a good person to talk about this, but it says that the lower humor group, negative life events affect them more. It looks like they might be a little more affected every time a negative life event happens. They get more upset than the high humor group. Okay, that's interesting. In each formula, X, let me change colors again. In each formula, X represents the intensity of a negative life event. So if you're going to define your variables, you would say X is the number of intensity, right? X is number of intensity. The higher the number, the higher the intensity. And then it should, does it tell us what Y is? I mean, we can figure it out if it doesn't tell us Y. Oh, D, it's not Y. And D is the average level of depression in response to that event. So D is the average, my dog is making funny noises, level of depression. Okay, so when I say the words defining your variable, this is what I'm expecting you to do. X equals and D equals, or Y equals sometimes. All right, let's see, what else? What is the actual question asking us? If the high humor group averages a level of depression of 3.5 or 7/2, because 7 divided by 2 is 3.5, in response to a negative life event, what is the intensity of that event? So what it gave us is a level of depression. So it gave us the D. Okay, so you can see below in the solution where D was in the formula, they instead put 7/2. And then the rest of the formula stayed the same. And we are going to try to solve for what is the intensity of that event, or what is the X. And this is really important to figure out what number it's giving you and what you need to solve for. If you put 7/2 in for X, you would get an entirely different number. Okay, and that just walks you through. It multiplies by the least common multiple, which is 18. So that's what it's doing here, just like we did in our other questions to get rid of the fractions. And then once it does that, it gets 63 is equal to 2x plus 15. Right here, 2 can go into 18 9 times, and 9 times 7 gave us the 63. Over here, 9 can go into 18 2 times, and 2 times 1 gives us the 2x, which is what we got here in the denominator, or sorry, at the bottom of the equation. And then 9 can go into 18 twice, and 2 times 26 is 52. Let me do that last one again. 9 can go into 18 2 times, and 2 times 26 was 52. And then it subtracted 52 from both sides, and they got 11 equals 2 times x. Then they divide both sides by 2, and they just get x is equal to 11/2. Or you could put it in the calculadora and you would get x is equal to, what's half of 11? 5.5, if you wanted to have a decimal. A lot of times the reason why books do fractions is because you will always have an exact number as a fraction. And here we have an exact number as a decimal because it doesn't have to be rounded. But if it had to be rounded, it would not be exact. So that's why we like to use fractions sometimes to get a better answer. So what does our answer mean? Our answer means that if you have a negative event, if you are a high humor group and you have a negative event of 5.5, which is a little bit above average, then your level of depression is a 3.5. Okay? And in tests, you will be asked to explain what that means. Okay? In the checkpoint that I want you to do now, it says use the model for the low humor group, which is what they mean by model is they mean the equation. So actually, let's go find it. So 10/9x plus 53/9. 10/9x plus 53/9. So D equals 10/9x plus 53/9. Were they both over 9? Let's double check. Yep. Okay. This is a 9 here. That makes it really easy because you're just going to multiply by 9 probably. If the group averages a level of depression of 10 in response, so the average level of depression is going to be the D value. D is equal to 10. What is the intensity? What was the intensity of the event? So you are looking to solve for X. Okay. So D is equal to 10. Solve for X. All right, proportions. I love proportions. A ratio compares quantities by division. For example, a group contains 60 women and 30 men. Let's see, what color do we want? Let's go back to yellow. Okay, ratio. Be careful, ratio is not always a fraction, but a group contains 60 women and 30 men. The ratio of women to men, so whatever comes first, if women comes first, that's on the numerator, so that's why we have 60 on the numerator. Men come second, that's why we have 30 on the denominator. We can express this ratio as a fraction, and then they reduced it right here. So they said that 30 can go into both of these numbers. 30 can go into 62 times, 30 can go into 31 times, so it's actually 2/1. A proportion is a statement that says two ratios are equal. if the ratios are, and then this kind of got messed up. Let me change this. Let me write over it. A and B and C over D, then the proportion is A over B is equal to C over D. We can clear this equation by multiplying both sides by B times D. So B times D are my denominators. If I multiply them together, I automatically get a multiple. So it is no different than what we were just doing to solve the last couple of examples. And then it goes and does this with just letters, but we can skip that for now. Or it says you can just cross multiply using the cross products, okay? Because what they did right here was prove why cross multiplication works. So it's up, it's up to, I just noticed something in the corner of your book. It has the cross multiplication here. I see people who like this both ways. I think cross multiplying is probably the easiest to remember. So let's go through these examples here. Example 7 is question A, 63 over x is equal to 7 over 5. If we cross multiply, then we are multiplying x times 7, and we get 7x. And then we multiply 5 times 63, and you get 315. After simplification, then to isolate the variable, because remember, we're still, every time we're trying to solve, you are trying to isolate that variable that hasn't changed no matter how much work we're doing. We need to get x by itself, so we need to divide both sides by 7. And after simplification, we get x is equal to 45. And then it checks its work. We're going to skip that for now. B, the first things it does is it does 20 times x, which just gives us 20x. And then it does 30 times x minus 10. Now this is very important. You must keep x minus 10 in parentheses because you have to distribute that 30. You're not just multiplying x by 30. You're not just multiplying negative 10 by 30. You are multiplying that entire denominator by 30, and that is why you have to distribute that 30. So after simplification, 30 times x is 30x, 30 times negative 10 is negative 30. 30 times negative 10 is negative 300. Sorry guys, after simplification. So we get 20x is equal to 30x minus 300. Need to get the x's on the same side, so we subtract 30 x's from both sides, which gets rid of this one. 20x minus 30x just gives us negative 10x. We have negative 300 left over here. Isolating the variable, we divide both sides by negative 10, and we get positive x is equal to positive 30. Okay. I like how it's using for our answers the solution set, and I think that that's leading up to the fact that this just has one answer, or these lines will cross one time if you were looking at them like that. Let's see. Here's your checkpoint. And I will say A, you should have no problems cross multiplying. B, when you cross multiply, I'll set it up for you. You get 2 times, and then parenthesis, 60 minus x, and you're going to need to distribute that 2 is equal to 22x. Okay. Applications of proportions. Okay. And it just gives you some, I'm going to probably be modeling this, solving tips. Okay. So write that down. I'll try to go through these. Oh my gosh, this is a long chapter, huh? Well, you might have to watch this in a couple. I'm just going down to see. Okay. All right, property tax on a house. And I love it when we actually get to applying things, because as much fun as I have problem solving and solving a puzzle and solving for X, I mean, really what the only reason we ever do this are so that we can apply it to our real life. So when we finally get to these problems of applying to the real life, I enjoy it. The property tax on a house with an assessed value of $480,000 is $5,760. Determine the property tax on a house with an assessed value of $600,000, assuming it has the same income tax rate. So represent step one, it's going through from above, represent the unknown by X. That is what most people will say as define the variable. In fact, I don't know why they say it like that. You've always heard it as define the variable. Okay, so they did that right here. X is equal to the tax on a $600,000 house. Okay, then setting up our proportion. So the $5,760 goes with the house that is worth $480,000 is equal to what we don't know. We don't know how much tax we are going to pay on a house that is $600,000. Now, you could have written both of these fractions the opposite way. That doesn't matter when you're solving this. What matters is that if the house price is on the denominator on the left-hand side, then the house price needs to be on the denominator on the right-hand side, okay? If it had been the opposite, you could have had the tax, both sides, the taxes on the denominator. So when we have a proportion, it doesn't matter which variable is on which side of the proportion, but it has to be the same on both sides, okay? So now they're dropping the units and cross multiplying. Technically, you don't have to drop the units. We just do that to make life easier for ourselves. So on the left-hand side, they have X times 480,000, which gives us 480,000X. On the left-hand side, they did 600,000 times 5760, which simplifies down to a lot, 3 billion, 3.5 billion. Geez, 1,000, 1 million, 1 billion. And then to isolate our variable, we need to divide both sides by 480,000. Okay, and when you do that, you get X is equal to 7,200. But remember what X is. X is the tax on the $600,000 house. So the tax on a 600, instead of writing X is equal to, you want to write the tax on the $600,000 house, which is how we define the variable, is equal to $7,200. Okay. So now for checkpoint 8, the property tax on a house with an assessed value of $250,000 is $3,500. So we can set up, we don't need to define our variable because we did it above. We're doing the same problem with different numbers. We can set this up by the tax over is equal to, and what does it want us to find? It wants us to find the property tax on a house with an assessed value of $420,000. So you're going to have the number 420,000, and X is going to be the amount of tax on that. So finish setting up that proportion and solving, please, for checkpoint 8. All right, example now, same thing. Oh, we used to do this in my algebra class. I wonder if you guys did this one. Wildlife biologists catch, tag, and then release 135 deer. I just watched a bunch of Shark Week, so I'm thinking about tagging the sharks into the wildlife. 2 weeks later, they observe a sample of 140 deer, 30 of which are tagged, okay? Assuming the ratio of tagged deer in the sample holds for all deer in the refuge, approximately how many deer are in the refuge. So 135 total tagged deer. I'm just going to write out what I know. And then I know when they caught them again, they got 30 tagged in the sample. And the sample, the second time they caught deer, there was 140 in total sample. Okay, so the way they set this up is, and we are looking for all deer in the refuge. So X is equal to all deer in refuge. Okay. So when you're setting up your sample, or when you're setting up your proportion, you are going to need to put the numbers that represent the sample, so tagged in the sample and total in the sample, that's going to be in one fraction. And in the other fraction, it's going to be the total tagged deer and the total number of deer. I wrote all, I should have wrote total so they looked similar. Okay. So the way they set it up over here is the original number of tagged deer, 135, over, oh, maybe I should stick with the colors that match what I did. They did 135 total deer over all of the deer. Okay, and that was what we did in green. And then the set it equal to the total tagged in the sample, and the total number of the sample. Okay, so the sample, the yellow is together, and the totals are together in green. Okay, and then they just cross multiply and solve. And they get that X is equal to 630. But remember, instead of X is equal to 630, they say, instead of X, the total number of deer in the refuge is 630. You always want to go back and put in, when you find your answer, you want to put that into a sentence using how you defined the variable. So some of you remember, I think of it as DSEA. Define your variable, write your equation, solve or evaluate, and then answer in complete sentences. Okay, so define your variable. This is how we solve real world situations. Define variable, write equation, solve or evaluate, and answer in complete sentence. So we just followed all of those rules. If you remember, I don't know if you guys remember Mr. Zelinsky, but he's the one that came up with that. Okay, so your checkpoint, what you need to do is they catch, tag, and release 120 deer back into wildlife refuge. So that's the total number tagged. 150 is the total number in the sample they re-catch. And 25 is the number in that sample that are tagged. So the two sample numbers will go together. And maybe I'll do that in green, and the total number of deer tagged is 120. So set it up just the same as we just did, and your proportion, and solve it. Please make sure you're writing out these checkpoints down on paper so that you have them ready to turn in. Equations with no solution or an infinite amount of solutions. An infinite amount of solutions, if you're looking at two linear relationships, means that they are exactly the same line, okay? So if this was one line and two lines had two equations had an infinite amount of solutions, remember a linear equation represents a line, a straight line, then, and another line was exactly the same. I was hoping that those would make blue. That would have been cool. If they're the same line, if they're the same equation, that means they touch at every single point. So they have an infinite amount of solutions. So if both sides of the equation are the same, they will have an infinite amount of solutions. And also, if you have two lines that will not give you an answer when you set them equal to each other, what that means is they are parallel lines and they will never ever touch. So instead of having an infinite amount of solutions, they have no solutions, okay? So what does that look like in our question here? If we are solving 2x plus 6 is equal to 2x plus 4, when you simplify both sides, you realize, and you can tell from right here, actually, 2x plus 6 is equal to 2x plus 8. I already know the slopes are the same, so that these two lines are going to be parallel. And since their y-intercepts are different, one is 6, one is 8, I know that they are not the same line, so I know they're never going to cross. So when you finish simplifying this, so what they did first is they subtracted 2 x's from both sides. Well, that literally canceled out the 2 x's and we got 6 was equal to 8. Well, that's not true, which means there's no solution. Okay, and when you, oh, I thought it was going to go right away. Okay, so try the checkpoint here, exactly the same thing. You can distribute that. 3 is the first thing I would do. Then we're going to get into what does it look like to solve an equation for which every real number is a solution. So this means after they simplify it, these should be exactly the same on both sides. Yep. So they distribute the 6 on this side and they get 4x plus 6. Well, that was already what we had on the other side. So these two lines are exactly the same. If you simplified it, you would literally just get 0 is equal to 0. Well, 6 is equal to 6, and then if you subtract 6 from both sides, 0 is equal to 0. So before we had 8 was equal to 6, which was not true. Here we have 6 is equal to 6, which is true, which means that those lines are the same. So there is an infinite amount of solutions. Okay, so the solution set is infinity. Your checkpoint is to do the same thing with this equation. To get started, I would distribute the 9 on the right-hand side. All right, make sure you have whatever notes you need written down and your checkpoints completed. We'll come back and visit those. Otherwise, I hope you've enjoyed this video and split it up so you didn't have to sit down like I did all at one time. And let me know if you have any questions.